Well, hello. My name is Lance. Today I'm talking about our ongoing work on modeling language about belief and theory of mind. So we use language to talk about other people's beliefs. For example, we might say Alice thinks that she might pass her exam. Note here we can use modal words such as might or could to indicate uncertainty in beliefs. We can also talk about other agents' past beliefs or false belief. For example, Alice thought that she passed her exam, but she didn't. So language provides a very rich medium for us to represent and express our beliefs about other agents' belief. So kind of thinking about thinking. So we're interested in how can we, how do we represent other agents' belief when we utter these statements, and how do we evaluate whether a belief statement is true based on agents' goal-directed actions. So to answer the first question on belief representation, according to Fodor's language of thought hypothesis, to believe something is to have a mental symbolic representation in your what he called belief box. And such mental representation have linguistic structures such as syntax and compositionality, and etc. So in our work, we formally represent these belief statements using epistemic logic statements. So consider a scenario where a player is playing a simple game where he's trying to find some keys in boxes, right? So we can translate statements such as the player believes that there is a key in either box 2 or box 3 to this first order logic statement that using extensions such, so there exists a key that is either inside of box 2 or box 3. Now we have a belief representation. How do we perform computation to evaluate the truth value of these propositions? Past work in cognitive psychology and computational cognition has established a very close link between beliefs, agents' goals, beliefs, and actions, which is shown on this little diagram on the left, where agents' belief and goals, we can define this as a forward model where agents' belief and goals can lead to a series of actions. And this can be captured by this Boltzmann rational model of agent selection. Action selection as a posterior probability of P of action t at time t conditioned on agent's belief and goals. Now, then we can invert that model to infer agent's belief and goals conditioned on agent's actions. This is called Bayesian inverse planning, or Bayesian theory of mind. I won't go into the model details, but you can follow this, our lab's early work by Chris Baker and al. In 2017. So now we have to answer the questions. We can put the two pieces together to evaluate belief statements. So again, consider the statement that the player believes that there is a key in either box 2 or box 3. We have an epistemic logic representation of this statement, and then we can enumerate over the agent's beliefs, as shown on the bottom, of all which is represented by all possible worlds and the posterior probability of these belief particles. And then basically we just have to find the belief particles that are associated with each belief formula, and then we can just sum up with these posterior probabilities associated with these possible worlds. And then we can get the truth value of these belief statements. So we run this on a very simple grid world experiment where this agent has to open up these little boxes to find keys in order to unlock these doors to find one of these little gems of different shapes. We recruited 100 participants and asked them to watch this agent play this game and guess what is the agent's goal, and ask them to rate these belief statements at different breakpoints of the trajectory on a scale from 1 to 7. And we show that our model on the very left has a very good fit of the human data when compared to other baselines. And as you can see, humans have very graded judgments of these belief statements, which indicate their very graded uncertainty, which is very well captured by our model. So yeah, that is a summary of the project. I'd like to thank my colleagues from the lab and also my PhD advisor. Please stop by my posters if you would like to discuss more about theory of mind.